Okay, this is lesson 69, properties of trapezoids and kites. We're going to start off with a couple definitions like we always do. All right, mid-segment of a trapezoid. So first of all, look over here to the right. There's an example of a trapezoid right there. If you remember, a trapezoid has one pair of parallel lines. And you'll notice that here with these arrow marks, that those two are parallel. So that is in fact a trapezoid. Now we're going to talk about a mid-segment of a trapezoid. It's the segments whose endpoints are the midpoints, so that's your first blank, midpoints of the legs of the trapezoid. So once again, you see these legs over here. It's the sides that are not parallel. The mid-segment is going to cut through the midpoint. So you notice right here, and let me get my highlighter out so I can draw your attention to it. So you notice these right here and these right here. They're trying to tell you that U and V are on the midpoints of those two legs, because remember, midpoint means it cuts it equally into two parts. Hence, this congruent to this, and this congruent to this. So, what we can surmise from that is, I'll highlight it over here, that the mid-segment is equal to half the sum of the bases. So this formula right here, you see where it says UV is equal to half QR plus TS. That's the formula when finding the mid-segment of a trapezoid. So let's practice applying this formula down here where it says the mid-segment of trapezoid ABCD, so this one right here, is EF. So they're telling us right off the bat that this is the mid-segment. They want us to find the length of EF. Find the length of EF. So let's apply that formula from up above. We're going to write EF is equal to 1/2, open parentheses, AB, which is 15, plus DC, which is 25. Plug that into my calculator or do some mental math. And what do you get? 20. Good job. 20 feet. That is the answer. Easy, right? As long as you remember the formula. Add the bases, divide by 2. Now, moving on to isosceles trapezoid. That is a trapezoid with congruent legs. Congruent legs. So, you notice right here, they're trying to tell me that this is an isosceles trapezoid with those tick marks right there. Those legs are congruent, so we know it's an isosceles trapezoid. Let's read the problem. It says base angles of an isosceles trapezoid are congruent. If trapezoid HIJK is isosceles, then angle H is congruent to angle I, and angle J is congruent to angle K. So let me get out some different colors here. I want you to see that these two angles are congruent, and I want you to see that these two angles are congruent. That's something that you can automatically know about isosceles trapezoids, which is really helpful when it comes to solving problems such as these. So it says, find the measures of angle N angle O, and angle P in isosceles trapezoid MNOP. Now don't let them trick you. Notice how they positioned the trapezoid vertically, like they rotated it. So be careful when you're looking at this one, right? Because that's not how they positioned it down here. So take a second to fill in those 3 missing angles and see what you get. All right, Harper, you start off. Tell me one of those angles.
N is also equal to 107 because it's congruent.
Yes, angle N is equal to 107 degrees. Anybody want to take a stab at P or O? What do you think?
P would be 180 minus 107, which gives you 73.
Nice work. And then that last angle? Also 73. Perfect. So I'm going to write down angle M is congruent to angle N, and both of those are equal to 107. I'm also going to write down angle P is congruent to angle O, and both of those are 73 degrees. And the only reason why we know that is because of the key words isosceles trapezoid. When we hear those key words, we know that the angles, the base angles, are congruent to each other. And I should probably write down too, because I like how Gabby explained, and I'll use a different color, that 180 take out 107 is where I found the 73 degrees. That way, if ever y'all look back at your notes, you know where that came from. It's always good to take notes as if you're going to look back at them in the future, having not seen it in a while. Okay, let's turn to the next page. More on trapezoids. Okay. This time we're talking about diagonals. So you see these two right here, these two segments. Those are called diagonals. And this postulate says that the diagonals of an isosceles trapezoid are congruent. So you'll notice right here, it says SU is congruent to TV. So these two are congruent. Now, when you hear isosceles trapezoid, you know the base angles are congruent. We just did that in the last page. We also know their diagonals are congruent. So there's a couple things we know now about isosceles trapezoids. And remember, the reason you know it's isosceles is this too. You see the diagram, how it has those 2 tick marks to show that the legs are congruent? So had they not said isosceles trapezoid, you would also know from the clues drawn in the diagram. Okay, let's use this information to solve that next problem. It says ABCD is an isosceles trapezoid, and we know that from these tick marks. They want us to find the length of segment CE, so that's right here. If AC is 22.3, where's AC? So that's 22.3. And AE, where's that, is 8.9. So the whole thing is 22.3. Part of it's 8.9. They want us to find the other part.
Don't you just subtract 22.3?
That's all you do. We don't need to make it harder than what it needs to be, right? We know that AE plus EC, or CE, same thing, equals the whole thing. So if AE is 8.9, and we know the whole thing is 22.3, we can just use algebra, just like Logan said. We can take 8.9 from over here and move it over here so we can find CE. What'd y'all get?
13.4.
13.4. Good job. Stop me if ever I lose you guys on any of this. Okay, last postulate that we're going to cover today. This time it's about a kite, so they're switching it up on you. But no different in the sense that these are the diagonals of a kite. So when you hear the word diagonals of a kite, I want you to know that that's what they are referring to. All they're trying to tell you is that the diagonals of a kite are perpendicular. Actually, no, let me do this. All that means perpendicular. That little square in the diagram, that means perpendicular. This little upside down capital T, that means perpendicular. And obviously, the word perpendicular. All right, let's apply that postulate to this problem down here. It says, find the lengths of the sides of kite W, X, Y, Z. So, just to make it clear, they want you to find this, 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 this. Find the sides. Round to the nearest tenth. Round to 1 decimal place. Okay, what do we know about the diagonals of a kite again? What did we just learn? Thank you. They're perpendicular. These are 4 right triangles.
You just take 1/2 base times height, all of them?
Not 1/2 base times height. That's not going to give me the side lengths. Pythagorean theorem. Pythagorean theorem is going to give me this. And we know, you see these tick marks? If we find one, we found the other. And same here. You see this double tick mark? If I found one, I found the other. So, do Pythagorean theorem to find the sides of the kite. Okay, Kellen, when you get a second, walk me through one of them, either one.
Okay. So for the first one, you are going to do 4 squared plus 5 squared equals c squared.
Good.
So you're going to do 16 plus 25, which is 41. And then you're going to do the square root of 41, which is 6.40.
Perfect. So both of these are 6.4. Good job. All right, Gabby, do you feel comfortable leading me on the other one?
Yeah. So you would do zy squared equals 8 squared plus 5 squared. And then 64 plus 25 is 89. So then you would do zy squared equals 89, and then cross it, and then zy is 9.4.
So both of these are 9.4. Excellent job, guys. We found the links and we rounded to the tenths place. All right, any questions before we move on to lesson 70? We're good? Okay. What you're going to find is this is really no different than the other lessons that we have learned when it comes to surface area and volume. It's just this one is specific to pyramids. But if you remember, we really just follow the same exact formulas, but it's just a different shape. So don't let this be overwhelming or daunting. I do want to go over a few key terms. So we know this is a pyramid because they all come up to one vertex. I want you to know that this is called the slant height, which is important whenever we work these formulas later. Don't confuse the slant height with the perpendicular height. Okay? This is the lateral face, meaning it's sideways. This is the base that it sits on. So not the vertex, right? But the side opposite the vertex is the base. And then like I said, the altitude is different than the slant height. Do not confuse these two. All right, now let's practice working some of these. We know this is a pyramid, right? One vertex. It says, what is the lateral area? What is the lateral area of this regular pentagonal pyramid? Now, had they not given me this diagram, would y'all know what pentagon means? Because you need to know that. Very good. Pentagon means 5 sides. So I'm just going to write that above the word pentagon. Luckily enough, they gave us a diagram to go with it. So even if we didn't know what pentagonal meant, we could see 1, 2, 3, 4, 5 down at that bottom. Okay, so lateral area. Let's look right here. This is the formula we're using. So I'm going to write down lateral equals 1/2 perimeter. Remember, P stands for perimeter. And this L stands for slant height. And actually, I'm going to have you write that. Let me get my pen back out here. This right here, perimeter. Doesn't hurt to write it out so that way when you look back. And it's important to write slant height here because that's not obvious. A cursive L is not obvious for slant height. And I might even want to write it over here next to this thing. So on this diagram, put a cursive L next to the slant height. All right, now we can move on. Okay. So we need to find the perimeter. Any thoughts? How do we find the perimeter of this base down here?
5 times 2.
Thank you. Too easy. So 5 times 2, which is 10. And we already know our slant height. Very good.
So
Our
it's
slant
15.
height is 5. I'm going to highlight it like that so you all know the green and the green go together. Okay, time to plug in. So, lateral equals 1/2 perimeter, which we said was 10. Slant height, which we said was 5. We got it from over here. If you're wondering, this came from here. This came from here. And now we just calculate. We just evaluate. What do y'all get?
25.
25. Did it give us any units?
Centimeters squared.
Yep, centimeters squared because it's lateral area. All right, good job. That was lateral area. Now we're moving on to surface area for this next question. Logan, will you read it for me?
Calculate the total surface area of a regular hexagonal pyramid with a slant height of 12 centimeters and a base side that is 3 centimeters long.
All right. What does hexagonal mean? Notice they did not draw me a diagram.
6 sides.
Very good. Hexagonal means 6. We need to know that. All right. Surface area formula. Let's look up here. It includes L, which is that formula, plus big B. What does big B mean again?
Base.
Not just base. It means area of the base. Here, let's write that in. Area of base. That's what big B stands for. So S equals L plus B. Let me write that down. S equals L plus B, which means lateral area plus area of the base. And remember, lateral area is equal to 1/2 perimeter slant height. Okay. How do we find the perimeter if each side is 3 centimeters and there's 6 sides?
6 times 3.
6 times 3, which is?
18.
So our perimeter is 18. And our slant height is
12.
12. Okay, we can find our lateral. Lateral equals 1/2 perimeter. We said 18. Slant height, we said 12. Punch that in and tell me what y'all get.
108.
108. Okay, now that's just this, right? We found this, but now we need area of the base. This is where it gets tricky and I need your undivided attention. Okay, I'm going to draw it over here. It said hexagonal. I'm going to draw it as best as I can. There's my hexagon. And it said well, let me write down the formula first to remind you. Area equals 1/2 apothem times perimeter. Remember that guy? 1/2 apothem perimeter. Do y'all remember that the apothem is this? Which that's not drawn well. Let me try that again because it needs to be more centered. That's a little better. Okay, there's my apothem. They said the sides are 3, right? So that means that this is 1.5 cut in half. And there's 360 degrees in a circle divided by 6 equals 60 degrees. So that must mean that this is 30 degrees because that's 60 and half. Because the whole thing is 60. Half of that's 30. Okay, so let me take this out so you can have a better look. And then this is 30 degrees. All right. This is a 30, 60, 90. And I have the short leg. And I need this side right here. That's my apothem, my A. Anybody remember how to find the long leg when you have the short leg? If you were to find the hypotenuse, you'd be correct. 1.5 times 2 will tell me this side right here.
It's an x root 3.
It is x root 3. So I'm going to write down 1.5 root 3. That's my apothem. So here we go. 1/2 1.5 root 3. And then the perimeter we said was 18. 3 times 6, right? Okay, punch that in your calculator. What'd y'all get?
It'll be 27 root 3.
I enter in the entire thing to where you get a decimal. I actually got 23.38.
Yeah, that's right.
Okay, good. 23.38. Punch that in, make sure that's what you get. All right. So now I have my big B right there. I have my L right there. So to find surface area, I need to add those two answers, right? My lateral and my area. So add 108 and 23.38. I'll use a different color. So surface area equals 108 plus 23.38, which equals, did y'all get 131.38 squared?
Yes.
Or sorry, centimeters squared. That's your answer. Okay, yes.
May I use the restroom?
Yes. Do you remember the code?
Yes.
All right. All right. I would say it's pretty self-explanatory except for this step right here. How are y'all feeling about the area of a hexagon and remembering to use this formula right here, 1/2 apothem perimeter, the 30, 60, 90 special right triangles. Notice how it's all coming together, everything we've learned. Did I lose you in any of that? Okay. Last problem. This time we are looking at volume. We've already done lateral. We've done surface area. And now we're doing volume. So we're going to use this formula right here. Remember, the big B, it stands for area of the base. So 1/3 area of the base times the height. So let me write that down. Volume equals 1/3 area of the base times the height. Okay. Harper, will you read that one for me?
Find the volume of the pyramid. The height is 9 inches and the base is a right triangle with legs that are 5 inches and 8 inches long, respectively.
Okay. Well, I think y'all can handle this one without me because y'all know how to find the area of a right triangle, base times height divided by 2. And they gave you the altitude, which is the height of 9 inches. So y'all try to solve this one on your
Do
own.
you turn like the paper this way, like that will be your base?
Uh-huh. So base is 5.
And then your height's 8.
Mm-hmm. And remember, area of a triangle, base times height divide by 2. A lot of people forget to divide by 2. Okay. Kellen.
I
Oh.
didn't finish.
Oh, it's okay. Don't rush.
You divide by the 1/3, right?
Correct. Divide by 3.
Okay.
All right. Talk me through how to find the area of the base,
Okay.
the triangle.
So, I did 8 times 5, and then I got 40, and then I divided it by 2, and I got 20.
Very good. So the area of that triangle is 20. And then, so you plugged it into the formula 1/3, 20, and then what's the height?
9. So
9.
I multiplied 20 and 9.
And what'd you get whenever you...
180.
Uh-huh.
And then what did I get for my final answer?
Yeah.
60.
60. And how'd you label that?
Inches cubed.
Very good. Inches cubed, because it's volume. All right. Now go ahead and try the lesson practice and see if it really all makes